more reasonable with this kind of notation. Huh? So first of all, I thought I could do it later, but I need one more observation, which is what? You have n and whole numbers. Then 10 to the n times 10 to the n equal to 10 to the n plus n. This should be completely non-controversial. Yes?
What? Really?
You don't believe that? Why you don't believe that?
I believe it, but I don't know if it's completely non-controversial or.
Oh, really? Oh, let's see. What does this mean? 10 to the n. What does it mean?
10 with m number of zeros.
No. What's the definition of this? What's the definition of this? Definitions. I told you here you have to know definition. 10 times itself how many times?
No.
M times. And this means what?
Same thing.
No, not the same thing.
N times.
N times. You multiply them together. How many times of 10 you're multiplying?
N times M and N.
Which is what? M and N is what?
M plus N.
Don't think it's obvious? Don't think it's obvious? You still don't think it's obvious?
Not really, no.
Why not?
I'm not sure why. Yeah, I think I need to see
10 times 10 times 10. Okay? Multiplying itself 3 times. So you multiply itself 2 times. Alright?
Yeah.
This is 3 times, 2 times, right? And multiply together, how many times is that?
5 times?
Yes. What's 5?
3 plus 2? Okay, now obvious.
No time. Good. Right? So if it's, I say it's obvious, you don't agree, then obviously we have to make sure that you agree it's obvious, right? I mean, it is obvious, right? Now, by the way, this might look blah. I mean, just you say add and then nothing to it. But suppose I tell you 10. I mean, would you say this is believable? Do you believe this? I hope I got it right. Now, by itself, I don't think anybody can tell it's obvious. Right? You can't even begin to think about, what this is what? This says what? Add 1,000 to itself 100,000 times. What is that? Who knows? Right? But in this, you feel this obvious. And you realize this is nothing but the statement 10 to the 5 times 10 to the 3 is 10 to the 8. Right? 3 times 10 to the 8. That is obvious from this point of view. See? So that's one thing you learn about mathematics is that sometimes all it takes is you look at things what we call the right way. Then suddenly it's like a shaft of light suddenly shining on something. You say, "Oh, it is obvious." So that's a good example. Okay. Now we're in business. Alright? I do it any way you want, but this is now I write it at 10 to the 4. form, right? So yeah, I should not skip this. Okay. So I should not skip. Yeah. 5, 8, 7, 3. And 4 times. I'm going to write it out in expanded form. Alright, it's 5 10 to the 3 yes, plus 8 times 10 to 10 squared plus 7 times 10 plus 3. Yes?
Yep.
Now, I want to multiply all the way through. And what do I use? Yes. So you see? Alright. But what I see myself instead, I'm going to multiply this into every one of the summand, what I call it. Right? But I know that when I multiply 3 numbers, I don't care how you multiply. You can do any order. Right? So obviously, it's to my benefit to do this. I multiply not to 5, but to this one. If I do that, it's what? 10 to the 7. 3 plus 4 is 7. You agree, Manny? Good. Again, this I multiply to here. I don't multiply to the 8. I multiply into this. It's 10 to the 6. Okay? Plus 7 times. Now you remember. This is actually 10 to the 1, remember? Okay? So it's 10 to the 50. Plus, just go 3 and 10 to the 4. That's it. Now you write up the non-expanded form. You know that's 5, 8, 7, 3. You know it's there. Where they are, that's the issue, right? This is 10 to the 7. Now the funny thing you have to realize, by the way, like this. This is 10 to the 3rd. You all agree because this is 5,000. You all agree that. Now, so that's obvious. But from another point of view, this is very awkward because why? You count like this. This is not the 3rd place.
Yeah.
The 4th one. Actually, be careful. So 10 to the 7th, that means this should be in the what? Not 7th place, but what? 8th place from the right. Yeah? So that means 1, 2, 3, 4, 5, 6, 7. Yep. Right. Now you make sure it's okay. 8, is this in the 7th place? Yes. 7, is it in the right place? And so on. So that's what it is. It's not simple, do you agree? Not simple. It takes work. But you get an opportunity to see how symbolic notation is used. You get to understand what place value is. That's what we call true understanding of place value. Not the kind of talk you just keep saying. There are all kinds of things you can say about place value. But nothing I would venture to say that is comparable to the amount of information compacted into the field landscape. You need a lot of understanding to get to this point. That's what that is kind of what we call conceptual understanding. That's the real conceptual understanding, not talking. So, is this okay? Any questions? Oh, of course. mean, I should up the ante by putting in 10 zeros or something to impress you even more, right? But you get that. Yeah. Now, so you would say, in some sense, you say, well, that's cheating because what have you done? Well, I mean, when you think about it, what it says is that, you know, that's something. This is just too complicated. This is what? Adding 5, 8, 7, 3. What's it, 10,000? Yeah, 10,000. Who has done that kind of addition? Nobody has done that. You don't know what it is. Even the other way around. Add 10,000 to itself, 5,080, whatever. After a while, you lose track, you can't keep track. So you vaguely know how big it ought to be, you know, it should be roughly 5 followed by 7 zeros. You get that kind of magnitude estimate. But we're not interested in roughly what it is. We're saying precisely is that number. You have to have a method to keep count, right? And that's what you have to do then. Be very precise your understanding of everything involved and come up with a resolution. That makes sense. So that's the thing. Then I'll stop for a little bit, see if you have questions, and we'll get through. In this one, by the way, right here, I've almost summarized the whole morning's work, right? In 3 lines. Everything we have talked about comes into play. Everything.